All right. I was instructed to speak very loudly so everybody can hear me. So here we go. So today I'm going to talk a little bit about semantic SQL and specifically building a dynamic semantic layer on top of Iceberg with SDF. I'm Lucas, and with me here is our newly minted director of growth, Kendrick. And let's take it away. You're welcome. That was shortest slideshow in history. All right. So why are we talking about the semantic layer? Because at least in data engineering, that's where people at this point need the most support. So if you look at sort of the data development lifecycle, there's a huge amount of effort spent at the top, right, in the ideation phase, tons of tools around dashboards and visualization tools, and there's a ton of query engines that optimize the running at the end, right? And there's got vectorized in-memory engines, we have out-of-memory engines, graph databases, etc. But the part that the developer spends a lot of time with, right? The actual like, hey, let's write a SQL query and make sure that all the types are correct and that it can execute successfully. That's the part that has been really, really lacking in data development. So that's where SDF comes in. But first, why are semantics so important? There's this whole history of software engineering where a huge amount of time has been spent in building these robust type systems for software, right? You have Rust with its incredibly powerful type system. If you look at JavaScript, what happened there is TypeScript came along and people were like, yes, it's very nice to know that an object is a person and not just any object. And now we have TypeScript, and it's really starting to take over the JavaScript development ecosystem. And in SQL, we're kind of stuck in the Stone Ages, right? Like there's varchars, decimals, integers, and maybe date times, right? There's very, very few higher order types that you can work with as a developer. And this is very, very painful, especially when you're working at scale. And we're talking about Iceberg here today. A lot of the companies using Iceberg are really operating at massive scale, right? So tens of thousands, hundreds of thousands of queries. How do you make sure that types are semantically correct? That's where SDF comes in. So we built and are building SDF, which is a different sort of SQL compiler that will actually ingest multiple types of SQL dialects, compile them, make sure that they are semantically correct with static analysis, and take in additional metadata from places like Iceberg or from an ML model and compile them into a logical plan so that we can run powerful static analysis checks on top of them. We can write things like code contracts that execute just on SQL code, right? We never have to hit a database, right? We can just execute these contracts on SQL code. And therefore, even at scale, you can actually have this powerful data quality layer that hasn't really been possible before.
So just as Iceberg delivers a compute-agnostic data format, SDF, we're pioneering an agnostic compute layer. So FDF sits on the compute layer and enables data engineers and analysts to build and create business logic as code. Constructing a system of SQL statements that are organized, type correct, semantically correct at scale, and with all these different tools and options is a huge undertaking for most teams. The SDF CLI is built on Rust. It's extremely quick, and it connects directly to your data lake, whether on AWS, Snowflake, Azure, Google Cloud, and it automatically parses your data files to establish column-level lineage, and it allows us to create type classifications, enables code contracts, and you can even run code reports. So in addition to that, we have a web-based SDF console where you can access your data catalog, your data lineage view. You can click into certain items and figure out how things are working through your system. And you also have the ability to identify errors and unused columns and even establish alerting and notifications. Lucas is going to jump through a quick slide-based demo for us, but in this example, I just wanted to quickly call out how it's going to work. SDF connects directly to AWS Glue, which is holding the schemas in an Iceberg format, and we're using Presto Compute, and we'll showcase how to build a classification as well as code contract and report. Over to you.
Cool. All right. As you can maybe tell, this is not a full-on demo. The reason is we only had the opportunity to add slides. So we're going to go through some real code, but in slide form, which is maybe even more exciting. Yes, thank you. All right. So the quasi demo. Everybody probably recognizes this as a Visual Studio Code. editor. We're scaffolding here the TPCH queries because everybody loves TPCH. On the left, we have our queries. And in the center screen, we have an SDF scaffold. And the scaffold looks just like a project file. And we have an include statement where we include some queries. And this is great. Additionally, we want SDF to actually connect to Glue and pull schema metadata. So we run this SDF auth AWS command, and we're going to tell SDF to actually natively use my demo SSO profile on my laptop. My laptop, I promise. And once we've done that, we actually have sort of the first of two of three main components, right? We have code in Git. We have an AWS connection to Iceberg and Glue. And now the last part that we need is our semantic layer. So let's add that. If you run an SDF compile, we'll actually pull in schema metadata and check and make sure that that the queries that you have in your Git work with the schema metadata that's available in Iceberg. Then we can add a classifier, like in the top left. We're going to say, hey, we have some currency and we have some personally identifiable information, some PII. And in the right editor, we have the customer table. And we're going to say that the columns on the customer table of name and what else is there? Address and phone, that those are various types of personally identifiable information. Great. Ultimately, once you have this metadata defined, you can run SDF compile again, and you'll see in the bottom that now even in Q15, which we never touched, we know that revenue is some currency, or that in some external table that the column CNAME is some PII.name. How does this work? Internally, SDF will take a classifier at ingestion and propagate it through the warehouse down to any downstream transformation or table. And that way, the type system is dynamic, right? If you change a classifier at the top, it changes downstream at the bottom. It's a very different approach to ML-based solutions and looks a lot more like a traditional compiler that you would see in like Cargo and Rust or something like that, right? Where you actually use static analysis to propagate type information rather than using ML or something else to just point in time verify that a certain schema is a certain type. Cool. Next part of the demo. Now we have all three things, right? We have some semantic information, we have our AWS connection, and we have some code in Git. Now, I, as a developer, I want to make sure that I'm not going to violate any internal company policies. I want business logic as code. So now that we have this, we can create little code contracts that we call them code contracts. And a code contract is basically just a query on the information schema to make sure that certain business logic holds true. In this case, we have one at the top that says, hey, select for me the columns and the classifiers that are in an external schema and have a classifier like PII. If we have that classifier, we know that there is a type problem, right? We want that schema to maybe be free of PII. If that query returns anything, we have a problem. So we run SDF test. The code contract fails, and SDF will actually show you exactly which column in which table has the classifier that is offensive to your business logic. So this is a completely different way to look at data quality, right? Usually data quality means, hey, we're going to scan a bunch of tables. We're going to make sure that there's no nulls, and we're going to do outlier detection. This can only happen after the transformation has run. SDF, the idea is we want to statically verify code before it ever makes it to production and make sure that contracts and certain business logic can never be violated in the first place. Sweet. And finally, just to prove that it's all real, even though it's a slide deck, we have a code report. And that code report says, hey, give me all of the personally identifiable information in this warehouse. And after propagation, we run this a little query. We say, hey, give me everything in this warehouse that is like PII. And we now have a little report that automatically shows you where all the PII is in this data warehouse. Thank you. Who knew TPCH could be so exciting? And yeah, have a great rest of your day.